And now we are going to be talking about vector addition, subtraction, scalar multiplication, and dot product. Well, that part is easy. Suppose you have vector A and vector B given by these numbers right here. And this is, let's say, my pictorial representation of vector A. So this is my vector A, and let's say this is vector B. And you want to add them together. Well, that's easy. Just add the corresponding components. Just add 2 plus 3. Okay, 2 plus 3, and that will give you 5. Add 3 plus 2, 3 plus 2, and that'll give you 5. And then add 6 and 5, 6 and 5, and that will give you 11. This is how you perform vector addition. Pictorially, visually, this is how you do that. You actually draw vector A first, right here, and then you connect. This is called the tail of vector A, and this is called the head. Then you connect the head of this vector A with the tail of the vector B. So my vector B would be like this, something like this. And then this is my vector B. So then you connect this vector A, the tail of the vector A, with the final, with this head of vector B. And this one is your A plus B. So this is like a visual, a pictorial representation if it helps you understand. So for example, suppose you have basket 1 and basket 2. Basket 1 has 2 apple, 4 banana, 1 kiwi. Basket 2 has 3 apples, 2 banana, and 4 kiwi. If you combine basket 1 and basket 2 together, you will get 5 apple, 6 banana, and 5 kiwi. So this is one way to visualize vector if it helps you understand. One of the conditions for these vector addition subtraction to happen is that the size of the vectors should be same. So for example, here my vector A is 2 3 6, and this is my vector B 3 2 5 7 7 8. Here I have 3 elements. In this particular instance I have 5 elements. I cannot perform A plus B. That is not possible. Now let's look at vector subtraction. Suppose I have vector A and vector B, and I want to do subtraction. So in this case, all I have to do is just do subtraction of the corresponding elements or corresponding components. So 2 minus 3, 2 minus 3, that will give you minus 1. Then you do 3 minus 2, that will give you 1. And then 6 minus 5, that will give you 1. So this is how you perform A minus B. So suppose this is your vector A with this direction right here. And suppose this is your vector B right here. So your minus B will be actually in opposite direction, would be something like this. This is going to be your minus B. So what I'm doing, I'm just taking this vector A and I'm connecting with this vector minus B like this, and this is going to give you your vector A minus B. So this is a visual representation if it helps you understand. Now, the condition is same. The sizes of vectors should be same in order for subtraction to work. And now scalar multiplication. In this particular instance, you multiply a scalar by a vector. Suppose your vector A is 2, 4, 7. Then your 5A would be written with something like this. So you're going to multiply 5 by 2, you're going to multiply 5 by 4, and then you're going to multiply 5 by 7. This is exactly what I'm doing. 5 by 2, 5 by 4, 5 by 7. And the answer is 10, 20, 35. Now since I multiply 5 by the vector, what just happened? Every single element got multiplied by that number. So if you think about it, if let's say this is your vector A right here, and if I multiply by 5A, so your vector got bigger. It actually got scaled up. On the other hand, let's say this is your vector B right here. And if this vector B I multiply by 0.5b, so in this case, it's going to scale down. The vector is going to become smaller because every single component, every single number in that vector is getting multiplied by 0.5, which is making the number half of that. An example would be basket. Suppose you have a basket. It has 2 apples and 4 bananas, and you do 5 times the basket. Well, in this case, 5 times 2 apple times 4 banana. You multiply 5 by 2, 10. Multiply 5 by 4 is 20. So you're going to get 10 apple and 20 bananas at the end. And now the dot product of two vectors. Suppose you have two vectors A and B given like this, A and B, and you want to perform the dot product. The formula is you multiply A1 by B1, multiply A2 by B2, and A3 by B3. In other words, you multiply these two elements together, you multiply these two elements together, and you multiply these two elements together, and then you add them all together. This is how your dot product forms. Now, one of the conditions for dot product is that the size of the two vectors should be same. So the size of A and size of B should be same. Only then you can perform dot product. Otherwise, it would not happen. So let's take a look at this example. Suppose I have vector A as 3, 5, 1 and vector B as 2, 4, minus 7. Then your dot product of A dot B would be given by this expression right here. So in this case, you are multiplying 3 by 2, 3 by 2 plus you multiply 5 by 4 plus multiply by 5 by 4 plus and then you multiply 1 by 7 and then you add with 1 times 7 and the answer would be 6 plus 20 minus 7 and the answer is 19. Let's take a look at this example. Here you want to perform dot product between a and b. Well, in this case dot product is not possible. That's because the size is different. This actually has 3 elements and this one has 1 2 3 4 4 elements, and because of that your dot product is not possible. And now let's try to understand the geometric meaning of a dot product. The dot product, it measures how aligned two vectors are. So suppose I have two vectors, vector A and vector B. This is my vector A right here, from here to up to here. And this is my vector B from here to here. Now, what dot product does is A dot B, that would be equal to magnitude of A times magnitude of B times cos of the angle between them. So this is the angle between A and B. So the magnitude of A would be the length of this vector, vector A, and the magnitude of B would be the length of this vector, vector B right here. So your A dot B would be equal to the length of this multiplied by length of this multiplied by the angle, cos of the angle between two vectors. That's what your dot product means. So suppose the angle between two vectors is 0 degree, like this right here, A and B, and they both are pointing in the same direction. So the angle between two vectors is 0. So it means that these two vectors, they are very similar, they have very similar direction. So your A dot B is going to be very positive. Let's take a look at this example right here. Here, the angle between A and B is 90 degree. This is my vector B and this is my vector A. So in this case, A dot B is going to be 0 because cos 90 degree is 0. So that means these two vectors are unrelated. That's what it means. Then you have 180 degree. 180 degree means, let's say you have vector A pointing in this direction and vector B pointing in this direction. So it means that A and B, when you do the dot product, it will come out to be negative. So it means that A and B, they have an opposite meaning. And now let's understand the concept of dot product in machine learning. Suppose you have one vector that will represent your one data, and then you have another vector. Let's say that could be your model parameters. So dot product in this particular instance, it will give you the decision score. It will give you the prediction. Suppose your X, this is your one of your vector. This is your size of room, number of bedrooms, and age of the house. Let's say this is how vector X represents. And W, that's the weight, will represent, let's say, the size weight, the bedroom weight, the age weight, like how much weight to give to these numbers, to these features. So when you multiply, when you do dot product with X and with W, that's going to give you a prediction on price. So for example, let's say your X, let's say you have a house that is 200 square feet. It has 6 bedrooms and it has age of the house is, let's say, 10 years. And let's say the weight given to each one of these features is 0.1. The weight given to bedroom is 5 and the weight given to 10 years is 2.5. So these are weights. So if you do dot product y equal to w dot x, it will be something like this: 200 multiplied by 0.1, 6 multiplied by 5, this is exactly what I'm doing, plus 10 multiplied by 2.5. 10 times 2.5, and the answer is 75. So according to this formula right here, your prediction of the house price will be 75, whatever the unit. It could be 75 lakh or it could be any other unit. And we can use dot product to find similarity between two vectors. And this is the formula we use: cos theta equal to A dot B divided by magnitude of A times magnitude of B. So let's understand this through a simple example. Suppose you have three documents: document A, document B, and document C. Document A says today is a beautiful day. And let's say you convert this into a vector. And vectors, let's say, comes out to be like this. I'm just making these numbers up. And likewise, let's say document B, today is my lucky day. You convert this into a vector. So this will come out to be something like this. And likewise, document C, the food made me sick. You convert this into a vector, and this will be your vector C right here. So let's say you measure cos of theta AB. That is the measure the cos of the angle between document A and B. And let's say you answer, by the way, I'm using this formula, the formula I just showed you. And according to this formula, let's say the answer comes out to be 0.7. I'm just making this number up right now. Likewise, you calculate the similarity between A and C. So cos theta A and C, that will give you, according to this formula, let's say the answer comes out to be 0.2. And same thing, you measure the similarity between document B and C. That would be between these two documents. And let's say the answer comes out to be 0.3 right here. So if you look at these numbers, 0.7, 0.2, 0.3, well, this is a big number, 0.7. That is the angle between A and B is very small. So that tells me that document A and B, they are very similar. So conclusion, document A and document B are similar. On the other hand, document A and document C are not similar. You can see that. Look at this number. It's very small. So anytime when you have smaller number, that means those documents, they are not very similar. If you have a big number, let's say closer to 1, that means that number, that those two documents are very similar.